Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli, the Computer Guy, and in today's project, we are going to be creating a self-contained Wi-Fi scanner. So basically, this Wi-Fi scanner you can take out to wherever you want to take it. It will scan for SSID identifiers, and then it will print those SSID identifiers out on the screen. For today's project, we are going to be using an Arduino Uno with Wi-Fi, and we are going to be using an I2C display. It's going to be a 20 by 4 LCD screen. So these are going to be the main components that we're going to be using. So this is entirely self-contained. As you can see, I have my little INE battery here connected into my Arduino Uno with Wi-Fi, and it is then printing out information on the LCD screen. And this is what we're going to be creating today. So the only warnings for today have to do with the I2C display that we're going to be using. So we're using a 20 by 4 LCD screen here, but the interface for it is something called I2C. So this is actually an addressable interface scheme. So essentially you can have multiple I2C devices connected to your Arduino microcontroller, and then they're communicated with using an I2C address. So just like you have a MAC address or an IP address in the normal Ethernet world, in the I2C world, you have an I2C address. Now, in the code that I will be providing in the notes, I will be inputting the address that this should be. So the default for this particular type of device should be a particular address, and that will be down in the code I give you in the description. But in case for some reason you get a knockoff or some weird version of this particular display, it may have a different address. And if that is the case, then you will have to use some code called the I2C scanner. So I have code also on elithecomputerguy.com. You can run on your Arduino. It will scan for I2C devices and then show you what the address for the I2C device that you have connected is. So if you put all of this together and for some reason your screen is not working at all, one of the reasons may be that you have the wrong I2C address pointing to this, and so you simply need to figure out what the I2C address is. Again, you go and do a Google search for or look on elithecomputerguy.com for I2C address scanner. You pull that up, you run that code, and that will give you the address. So that is one thing to verify. The other thing to verify is that if you're using the I2C with an Arduino Uno with Wi-Fi, many times with I2C, you connect the I2C to the A4 and A5 pins on your Arduino. So if you have a normal Arduino Uno without Wi-Fi, just a normal Arduino Uno, many times you connect the I2C to the A4 and A5 pin. That's how you get it to work. It is important to understand with the Arduino Uno with Wi-Fi, though, because of the processor that it uses, you actually connect directly to the SDA, SDL pins on this particular board. I'll show you when we go over to the workbench, but those are just the two things to keep in mind. Again, with I2C, I absolutely love I2C. I2C is a wonderful thing, but there's a couple of quirks. The one being the address, and then the two, depending on what board you're connecting to, making sure you connect to the correct pins. So with that, let's go over to the workbench so I can show you how this thing is built and how it works, and then we'll dive into the code. Okay, so here is our little project. Again, the thing that I really want you to understand about this is that this is completely self-contained. So we have the Arduino connected to a battery, we have the screen connected to the Arduino, and literally I can walk around with this if I wanted. So basically this is a complete project minus the case and all of that kind of stuff. You create some kind of plastic case or something for this, and then you have a device that you can actually use in the real world. So if I do the restart here, let me just show you what happens. So basically we're going to press the restart. The first thing we get is a little splash screen here saying it's a network scanner created by me on a particular date. Then past that, what we're going to see here is we're going to have 4 lines of information. So basically at the top, I just decided to put a title, so network scanner, so you know what this device is supposed to be. Then down here, it's going to say networks found, and then basically however many SSIDs it's currently reading. So literally as I played with it, it's now only reading 4. It was reading 5. 5. So this will tell you the total number of networks that it's found. Then down here, what we're going to have is we're going to have the SSID number. And so what this is telling you is what number of the SSID is printing out down here. So ETCG is number 5. We're going to wait a second as it goes through the loop again. Test 1 is number 1. Basement is number 2. Test 2 is number 3. ETCG is number 4. And then direct, this is a printer up there, is number 5. So one of the reasons I put this little SSID number thing here is just to identify when you're looking at the SSID that's being displayed below, just so you kind of know where you are in the scheme of things. Now, this was one question I had to answer when I was designing this particular project. Do remember, whenever you're designing projects, you're literally designing the project. So you have to decide how you're going to build it, how it's going to work. So when I originally wrote the code for this project, basically I had all the SSIDs printing out on the first page. So initially I had 4 SSIDs in my environment, and so all 4 SSIDs would just simply print out on the page. Basically you'd have the SSID, you'd have the Wi-Fi strength, and that's all you had. But then I had a question. What if I have 5 SSIDs or 6 SSIDs or 20 SSIDs? How was I going to write the code if I was in an environment with more than 4 SSIDs? So if I had 4 SSIDs, I could just print them out here. But then the question then happened is, well, what if you have 5 or 6 or 20 or 50, right? How would I deal with that from a user interface standpoint? So what I decided to do was simply put in this additional information here, and then just simply at the bottom scroll through the different SSIDs. So that way, whether you have 1 SSID or literally whether you have 100 SSIDs, it will simply scroll through. Is this the best way to do things? I don't know. I think for this particular project, it works well. But again, this is one of those things that you're going to have to be thinking about whenever you're designing your projects is, again, if you have 4 SSIDs, you can fit that all on one screen. But what happens if you have 5? What happens when you have 25? What happens when you have 105? How is your little device going to be able to cope? So with this again will be able to cope. It could scan through 105 SSIDs if it really saw. So that's just something to be thinking about there. Then on the back of this, again, I just want to show you this is an I2C. So this is an I2C connection, and I really like the I2Cs for screens. So this is kind of the standard screen. So this is a screen that used to be used a lot. This was kind of the default. And basically, if you look at it, okay, they're normal LCD screens. So this is a 20 by 4 LCD screen. This is a 16 by 2 LCD screen. The big difference is how they're connected. Right, this has all of these pins on the back that you have to connect to your Arduino to make this thing work. Again, once you connect all of those different pins, it works fine, it works great, but that's a lot of different connections to connect. It can be a real pain in the butt. What I love about I2C screens is basically all you have are 4 connections here. 2 are for power, so you have 1 for 5 volt, 1 for ground, so that's easy. And then you have the SCL and the SDA connections. Those then on the Arduino Uno with Wi-Fi will plug into the SCL and the SDA over here on the digital pin side. This is something to keep in mind if you're used to I2C, is because many times with Arduino Unos, they're connect over to the A4 and A5 pin for their communication, but because of the processor that's being used on the Arduino Uno with Wi-Fi, you do have to connect them to the SCL or the SDA. And basically that's all we have here. So for this particular project, again, the Wi-Fi unit's already built into the Arduino Uno with Wi-Fi, so we don't have to worry about that. The only thing we connect on additional is the screen. So we connect, again, 5 volt and ground over to 5 volt and ground. Then literally SCL goes to SCL, SDA goes to SDA, and you connect it together. The only other thing to keep in mind, and I'll show you this in the code, is then you do have an I2C address. So with the I2C, there is an addressing scheme. So in order to communicate with any particular device that's connected to your Arduino, you do have to give it the appropriate address. If for some reason your screen is not the default address that I'm giving you in the code, you run that I2C scanner. Basically, it's code that you plug into your Arduino. It will scan for I2C devices connected to the Arduino, and then will spit out what the addresses of those devices are. So that's really all there is to the project. So let's go over and take a look at the code. Okay, so here we are at the code, and as we can see, it's not too bad. It's about 71 lines of code. One of the big things, though, is up at the top, we are going to have to include all of these libraries. You're going to have to include the SPI library, we're going to have to include the Wi-Fi 9 library, the wire library, the LCD library, and the liquid crystal underscored I2C library. So for these particular libraries, I will leave the links down in the description on elithecomputerguy.com. It's important just that you have those libraries installed. If you go over to Tools, Manage Libraries, we can take a look. We go to the Installed Libraries. And then from here, basically what we're going to be looking for as we go down is we're going to need the liquid crystal library built in by Arduino. So we're going to need to make sure that's installed. And if we keep going down, the additional library will be this liquid crystal I2C library. This is the one by Frank de Brabander. We're using version 1.1.2. That's the current version that's out there. So both of these libraries will have to be installed. So do make sure you have the liquid crystal I2C library installed for this particular project, or of course it will not work. So let's close this. So then basically where we're going to go down is, since we have this liquid crystal I2C library here, we're going to be then creating an LCD screen. So this is going to be the LCD screen where you plug in a bunch of different information for the LCD screen. The important thing here is this is the I2C address. So the rest of this, just leave it as it is. Don't worry about it. This is the I2C address, so 0x27. So again, I2C is an addressable scheme, so the address for your device or your screen might theoretically be different. If it's different, then you would have to modify that here. The next thing we're going to do is create a string, and the string is going to be a network name. We are going to be using this particular string later in the code to modify the SSID that shows up on the screen so that it can actually fit on the screen. So remember, we have a 20 character, basically a 20 column by 4 row screen, which means everything has to fit into that screen. So one of the things that we have to do is, I have an SSID that's really long. So one of the SSIDs that I connect to is that Jet Direct printer that I have upstairs that has an obnoxiously long SSID. And so one of the things that I have to do is I have to actually shrink that SSID down to a length that I can fit on the screen, and also be able to give the strength of the wireless strength of the network. So that's where we're going to be using the string later, is we're going to take the SSID, we're basically going to shrink the full name of the SSID down to a smaller something that can actually fit on the screen, and then that's what we're actually going to print out on the screen. Then we're going to go down here, again we're going to do serial.begin. So this is for the serial monitor, so this is what will actually show up on the serial monitor of the screen, and then past that, this is where we are going to create our little splash screen. So something to think about when you're creating these kind of little devices is put a splash screen on there. Hey, advertise, 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 advertise. Who built this thing? What is this thing? Why should people care? So basically with this, LCD begin. With this, what we're doing here is we're starting the LCD screen, and we're saying that the LCD screen is a 20, so it's a 20 column by 4 row screen. We are then actually turning on the backlight. So you will notice when we went to the lab, I did not have the backlight on. So basically here, when we're taking a look at this, you'll notice I currently have the backlight off. The reason for that is I have the jumper set to actually have it off. So there's a little jumper on the back here, and if I put the jumper on, that will then turn the backlight on. The problem is as you can see, for camera purposes, it's now very difficult to see what's on the screen, and that's why I turned the backlight off for the demonstration. So the backlight, if you're looking at it in the real world, it's very nice to have the backlight on. Having the backlight on makes it a lot easier to see the screen in the real world. But when you're doing videos, turning the backlight off makes it easier for the camera to be able to see what's going on. So basically that's where in the code we're turning the backlight on for our users. I just use a little jumper back here to turn it off because, again, when I'm using the camera, it makes it very hard to see what's on the screen. So then we're going to come down here. Again, we're going to set the backlight to high, so we're going to set it on. Then when we're dealing with our LCD screen, what we're going to have to do is we're going to have to set the cursor. Wherever we're going to print out something on the screen, we have to set the cursor. So basically what we're doing here is we're saying in the 0 row. So this here is the column position. So this is the column position. This is the row position. And we start at 0. We start at 0. So basically in the first row, on the first column, we are going to print out network scanner. So again, remember this is the splash screen, right? In the second row, again, first column, we're going to print out by. In the third row, first column, we're going to print out Eli the computer guy. And in the fourth row, first column, we're going to say built May 2020. So this is simply going to be the splash screen that shows up. So again, if we go over and we take a look at this, so as you can see this here, if I do a reset, that's what we have. So network scanner by Eli the computer guy, built May 2020, and then it goes into that. So that's what we're doing with that. Then we go over and we take a look at the code again, and then we're going to go down. So that is the splash screen. Then we're going to have a serial.println scanning available networks. So that's going to be on the serial monitor. Then we're going to create a variable, an integer for the number of SSIDs. And so basically we have a function here. So Wi-Fi.scan networks. What that is going to do is it's going to give us the number of SSIDs that are around. So we're going to set the value of this to the variable num SSID. If num SSID equals -1, so basically if no SSIDs, no Wi-Fi signals were found, it will print out serial.println, couldn't get a Wi-Fi connection. That will be out on the serial monitor. While true, while it can't find anything. Then we're going to do serial.println, number of available networks. Then we're going to serial.println, again, the value for num SSID. So this is all going to be printed out on the serial monitor. Then what we're going to do here is we're going to do the LCD clear function. So this is an important thing to remember whenever you're dealing with LCD screens. Remember, LCD screens will simply write wherever you tell them to write, but they don't do anything you don't tell them to do. So one of the problems you can have with LCD screens is basically it starts overwriting itself, where what happens is basically you write text on the screen, and then when you write the next layer of text, it will simply replace whatever characters it needs to replace. But all those other characters that were on previously will remain on. So basically with an LCD screen, you really have to think about how you're going to be clearing the screen or how you're going to be clearing the line so you can put new information on the screen. So what we're going to be doing here is there's simply the function clear for the LCD, and we're simply going to be clearing the screen. Then we're going to come down here, and so we're going to say for, we're going to create a variable int this net. So this network equals 0. So we're going to create a variable, this net equals 0, while this net is less than the number of SSIDs. So the num SSID, this net plus plus. So we have a for loop here. So we create this net is going to be equal to 0, while that new variable is under the value of the number of SSIDs. It'll continue to loop, and at the end of the loop, this net is going to get plus plus. Then we're going to come down here. This is all going to be serial print line. So this is going to be printed out to the serial monitor. So serial.print this net, so the number, serial.print, and then I'm simply going to be putting a period there. Then serial.print the SSID, so Wi-Fi SSID of the number, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, serial.print, and then we're going to put a tab. So this puts a little tab space between the SSID, and then we're going to serial.println Wi-Fi RSSI.RSSI. So this is basically the signal strength. Again, the signal strength for this particular SSID here. Then we're going to go down and we're actually going to print out to the LCD screen itself. So we're going to say LCD set cursor to 0, 0. So basically what this is saying is the first row, first column, and then we're going to print network scanner. So we're simply going to print out that this is a network scanner. Then we're going to do LCD set cursor to the second row, first column. Then we're going to print networks found, and then we're going to print the number that's found. So num SSID, so whatever the value is there, we're going to print that out. Then what we're going to do is LCD set cursor to the third row, again, first column. And then what we're going to be saying is what SSID we're currently printing out. So LCD.print SSID space # for number. Then we need to do LCD set cursor. So basically we need to set cursor to the next thing that we're going to be printing out. So on the third row at the 7th space, we're then going to do LCD.print, and we're going to say this net plus 1. So this makes life easier for you. So remember, we start at 0 here. We start at 0. So if you said 0 SSID, that might get a little confusing for people. So basically all I'm doing is I'm adding 1. So on the first SSID, it will be 1. And then it'll be 2, 3, 4, 5, however many. So instead of going from 0 to 4, it will go from 1 to 5. Then we're going to go down here. We're going to do network name equals Wi-Fi SSID this net. So this is going to be that network name string that we created up above. And then the important thing, why we're creating this particular string, is we need to remove. So there's a function called remove. And so basically what you can do is you can feed that function a string. So the string dot remove, and then you can remove anything past this point. So basically, if the SSID is over 16 characters long, I want everything past the 16th character to be stripped out of it so it's short enough to fit on the screen. So that's an important thing here. Then we're going to set the cursor, so the 4th row, first column. Then the thing that we're going to do here is basically what this is I'm printing out, I'm initially clearing the line. So LCD.clear will clear the entire screen. I don't want to clear the entire screen because basically I keep the screen, the network scanner and everything else on the screen as it is. I do want to be able to clear the particular line so that I can write out the new SSID information. So what this does is going to clear the line. Then I'm going to set the cursor, basically the same place, 4th row, first column, and then we're going to do LCD print network name, right? So we're going to take the SSID, we're going to feed that to the network name. We're then going to use the remove function to shorten the network name to only be 16 characters, and then we're going to LCD print out network name. Then we're going to LCD set cursor, again 4th row, 17th position, and then here we're going to print out the signal strength. So Wi-Fi.RSSI signal strength for this net. We're going to print out, then we're going to delay for 2000 milliseconds for 2 seconds, and then that is what will get us our loop. So if we take a look at it, again, we go back to our little device here. Again, this is where we have the network scanner, networks found, it tells us 5, so this is the number of SSIDs that were found. SSID number that it's currently showing us is here, and then this is the SSID at the bottom. So we can see test 2, ETCG, and then see this direct HP thing? Again, that SSID was so long it was going off the screen causing me problems. So that's one of the reasons I had that remove in there, chopping off of the 16 character mark so I have enough room at the end for the signal strength. And so basically that's how this works looking at the screen. Let's actually plug this thing into the computer just to show you what the serial monitor output looks like. Okay, so I now plugged the Arduino into the computer itself. We can go to serial monitor and just take a look. And so now this is printing out the information for us. Again, from a troubleshooting standpoint, this allows us to make sure to know what the Arduino is seeing. Okay, so this tells us what the Arduino is seeing, and then we can verify that what's getting printed out on the screen is what it should be. So here, basically, again, we have scanning available networks, number of networks available. Then we have 0 period basement at -40, 1 period test 1 at 41. That direct jet office jet 8040, that's at 82. ETCG at position 3 is at 86, and test 2 is at 88. Right, so you can go back, and again, you can take a look. This is where you're getting all that serial print. Again, serial print this net, so the number, then we have a period, then we have the SSID, then we have a tab, then we have the Wi-Fi, the strength, the signal strength. That's getting printed out, and then it's just looping through, and that's basically what we have. So that's what this project looks like. So there you go. Now you know how to create your own Wi-Fi scanner using an Arduino Uno with Wi-Fi and a 20x4 I2C LCD display. Again, this is 100% self-contained. I got my little battery here. I got my Arduino here. I got my display here. I can take this around the facility and see what networks are being scanned. Again, if you're going to put this in what I would call a production environment, I would highly recommend you put this into a box or something, but you know how geeks are. you know, if I was walking around a production environment, I would probably be walking around like this going, okay, yeah, I got the signal. Yeah, we got the signal. But again, if you're going to be handing this to users, I would highly recommend you put it into a little bit more usable fashion. But I think this is an interesting project for a number of reasons. One, this actually gives you something that's truly useful. You really can just take this, and again, if you're going to do a site survey or if you're walking around an environment, you can see what SSIDs show up and what the Wi-Fi signal strength is, all in this one little self-contained unit. The other thing that's very valuable here is now that you know how to do this, you can start building on additional code. Again, imagine if you're going into an environment where you're going to be putting Wi-Fi devices. You're going to be putting Wi-Fi surveillance cameras. You're going to be putting like Wi-Fi voice over IP systems or something like that. Imagine writing code here where it'll look for a specific SSID, and basically if the signal strength is above a certain limit, so basically you're getting a good signal, it will give a green LED, and if it's below that signal, it'll give a red LED. And then you can literally hand that to your normal, cable installers or whatever, and you can say, okay, go around to all the places where we're supposed to put these cameras, turn this thing on. If you get a green LED, install the camera. If you get a red LED, don't install the camera and call me. That sounds stupid, but right? How easy is that? Like, that is just something that you can literally hand to somebody and say, okay, before you screw this thing to the wall, before you spend an hour mounting this thing to a wall, just turn this little device on and make sure you get a green signal, right? If you get a green LED light and there's problems past that, it's my fault, I'll deal with it. If it's a red LED light, call me first, right? That's the kind of thing you need to be thinking about as a technology professional and thinking about the solutions that you can create. Other things that you can do is, again, things like war driving. Probably one of the projects that we're going to do in the future, once I get a GPS shield, is what you can do is, again, since this is detecting the Wi-Fi SSIDs, one of the interesting things that you could do is you could add a GPS shield to this. It can be detecting the Wi-Fi SSIDs, and then you could be logging the geolocation and the SSID as you go around in an environment, and then later you might be able to use that for some kind of navigation tool. So basically, if you see these SSIDs, or if your device sees these SSIDs, that means you're most likely in this geographic area. Again, it's a little sloppy, but that might be some kind of interesting project that you might want to be able to do. So this is kind of like the foundation of some more interesting things you can do for doing basic things such as scanning SSIDs. So there you go. Again, the big thing, the only real quirk with this, the only real pain in the butt, again, I love I2C. I2C is freaking phenomenal. If you haven't played with I2C on Arduino, you've got to. It's great. But as they say, it comes with quirks. It comes with quirks. So again, if you're not used to using I2C, just do a little bit of research on it. The important thing to understand with I2C is that they are addressable devices. So the big things are each device has to have its own address. So if you have multiple of the exact same device on your Arduino, you might run into problems if they have the same I2C addresses. So that's one thing to keep in mind. But if you don't, if you only have one I2C device connected to your Arduino, just realize you do have to communicate with it on the appropriate address. If for some reason you got some weird screen or some weird I2C device that has a non-standard address, that's the only real kind of problem you'll have with this project. Beyond that, again, since we're using the Arduino Uno with Wi-Fi, do make sure you connect to the SDA and SCL connections on the board instead of A4 and A5. And with that, you'll have your nice, nifty, neat little device here. So, as always, I enjoyed doing this class and look forward to seeing you at the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos, or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.